So welcome to the webinar, How I Got X-Ray and Thermal Vision Across Our Public Cloud Infrastructure. My name is Elias Turman. I'm SVP of Marketing at Orca Security, and I'll be moderating today's event. So let's start off by getting to know our experts. Michael, can you please tell us a little bit about yourself and MRS BPO?
Hi, everyone. I'm Michael Meyer. I'm the Chief Risk and Innovation Officer of MRS BPO. I oversee risk management, security, and innovation initiatives here at MRS. We are a very large call center with 4 offices, 3 domestically, 1 internationally. And we cater to the Fortune clients, predominantly Fortune 100 with a concentration in Fortune 50.
Awesome. Patrick, can you now do the same?
Sure. Hi, everybody. My name is Patrick Pusher. I'm a technical evangelist here at Orca. So it's my job to sort of help tell the story of Orca like we're doing much today. And I come from a background of sort of a serial startup technologist with a really kind of focus on cloud security, was involved in early kind of CSPM efforts, some of the subject matter we'll talk about today, and joined Orca earlier in the year. So I'm really, really excited to be here today. Thank you.
And Michael, I feel like I might have cut you off a little too soon. Did you have something else, more background that you wanted to tell us about MRS BPO for yourself?
I'll just tell you, no, but very excited to be here today. Love Orca.
Okay, awesome. All right, let's pull up the agenda and give a quick run through of this. So we're going to talk about the evolution of cloud security solutions. Cloud security solutions through the ages, talk about the control plane and the data plane and how actually when you combine these two together, you can get some incredible superpowers. And then bonus, we actually have 6 risks we're going to talk about, not just 5. So a bonus risk there, hiding within every cloud estate. Michael will take us through some of his decision making in terms of selecting a solution, some of the results with Orca. Patrick will actually take us through a quick demo, and then we'll end with Q&A. So with that, I'd like to pass it over to Patrick. Take it away, Patrick.
Thank you, Elias. And yeah, we're going to start with just a little bit of background of how we've done sort of security to date. And, it's not a long list. First we've got agents, and agents are installed and maintained as another application that sort of runs alongside your important workloads, right? Agents provide visibility into what's running, some rogue activity on the host, they detect data that shouldn't exist, for example. The problem with agents, though, as I'm sure you appreciate, and as we'll talk about really throughout the presentation, is that you must install and maintain them just like your other applications. And when you don't, these workloads effectively become invisible and orphaned, which is a real challenge from a security perspective, right? Unsupervised workloads are a little bit like unsupervised children. They find ways to get in trouble. Another approach that's been used in the past has been the network scan, right? So network scanners probe resources externally looking for known configuration errors. These 2 solutions really have been the cornerstone of data center security for many years. If you want to understand a physical machine's security posture, for example, even today, you're necessarily using one or both of these technologies. And really, in fact, we still use these technologies in very modern public cloud environments where agents are used to run, on physical machines. They now run in virtual machines. Where network scanners were deployed as, physical devices, they're now deployed as virtual appliances in our virtual networks. And then in about the last 5 or 6 years, we've also added a 3rd category of security applications since adopting the public cloud, the CSPM, or the Cloud Security Posture Manager. CSPMs monitor the cloud config, the config itself, which networks I have and their attributes, contain which virtual machines, roles, password policy, those kinds of things. So just where does Orca sort of fit in? If you're familiar with the Gartner terms of CSPM and CWPP, a CSPM, again, is a Cloud Security Posture Manager. It reads the configuration of all of the security controls and dials at your cloud of choice by API. And it's really good at measuring, a wide variety of services you consume there, but at a relatively shallow depth, right? The only kinds of measurements that can be done by a CSPM are those kinds of things that can be told to it by that cloud API, whether it's, AWS, Google, or GCP. So, it's wide. One of the drawbacks is that, you don't get certainly deep into findings, for sure, not into what we call the data plane, right? The data in your workloads, the data in your storage buckets. That's really not the role of a CSPM. Whereas a CWPP or Cloud Workload Protection Platform has to do with, an agent-based install into your workloads, trying to identify all the vulnerabilities, malware that exist in those workloads. So its visibility isn't at that cloud control plane, if you will. It's down at the virtual machine layer, and it's good at sort of memory protection, runtime protection. That's what it's best at. One of the disadvantages, though, as we'll talk about consistently throughout the rest of our presentation, is that it's agent-based, right? And so you're looking at per asset integration to have them sort of known and covered, which is a challenge. There's also a real lack of context because that agent sits only in that workload. There's a lack of context around what's around that workload, and we'll talk about how context plays into many things, including kind of this notion of alert fatigue. Whereas with Orca, we're really doing the best of both worlds, right? We're doing those same measurements of a CSPM, but we're getting down to that data layer, whether that's in your virtual machines, in your containers, in your storage buckets, or in your databases, and we're looking at the actual data identifying risks as well. So really sort of cutting through both what a CSPM and a cloud workload protection platform does. Because of course now we're looking at more, we have the visibility of of kind of your whole cloud estate, if you will. The best at context, obviously, a platform that knows both the risks in your workload and what surrounds it from a technology perspective, and considers all that, will tell you the most about your environment. And the disadvantage is that Orca is purposefully built for the public cloud. Doesn't run kind of within your data center. We think there are simply too many assumptions that are different between the two, so we've really focused on the public cloud. So one of the things that that's interesting to me when I look at the kinds of things from a host-based perspective that we find, including keys and malware, I often think, okay, it's great that the platform can tell me this. Many can't, but what's the next question I might have, right? If I find, for example, kind of a rogue SSH key in a workload, one of the very next questions I might have is there anything else in my environment that it provides access to? Right? If I find malware, certainly in that case, I would want to know, is the machine that I found it on quarantine from a network access perspective? So, can I contain that damage? Is the machine even turned on? And that may seem, compared to traditional kind of approaches to finding vulnerabilities in malware, that may seem a little bit silly, detecting something when it's off. An agent-based approach can't do that, but certainly one that looks at, the underlying kind of storage, and we'll talk about that in a moment, doesn't depend whether the machine is running or not. And so, if the machine's off, I can breathe easy that I can go and kind of quarantine that machine and kind of deal with the malware problem later. If it's on, and especially if it's focused, towards the public internet, I have more concerns. If I find that rogue key that a developer has embedded in a test script, for example, I might want to know, is it for the accounts I control? Is it for one that they set up to do some testing? If it's for one that I control, which user does it belong to, right? I have to sort of go back and find the root cause and correct it, and that's the information I'd want to know. And then if I found, misplaced PII, and whether that's in, email addresses or social security numbers or credit card data, anything like that, the next thing I might want to know is where I found that data, is it public? Can it be, sort of viewed from the internet at large? Those are all, at least for me, those are all the questions I would have immediately following on, these findings. And they're also the questions, or the answers rather, to what a platform that understands context can really tell you.
And I'll tell you, Patrick, that's really important, because that context, so many people, when you're charged with looking at security throughout the organization or the enterprise, one of the main issues is getting all these different alerts. You might get 10,000 alerts, 100,000 alerts, 1,000,000 alerts a day, a week, a month. How do you know what they are? Because the context is within the alert, you're able to determine these different issues and understand them much better than pretty much any other tool on the market. It's really a very useful thing that Orca's done.
Well, thank you, Michael. And it's a great point around, how do we get past this notion of, the dreaded alert fatigue? And it's a great sort of segue into, our introduction into this, the not 5, as Elias alluded to earlier, but the bonus six risks inside every cloud estate, and you'll notice it's absolutely number 1, and it's number 1 for a reason, right? We'll also cover workload coverage, right? And that has to do a lot with the deployment model, agent scanners versus kind of the whole cloud estate approach with Orca. We'll talk about vulnerabilities and malware, misconfigurations, lateral movement risk, and lastly, authentication risk. So let's start with kind of the last subject we talked about, and alert fatigue, right? There's multiple reasons here. I think it really boils down to 2 things, and one, and Michael, you just touched on this so beautifully, right? If we alert on every single software vulnerability in your cloud estate, you are going to be in any sort of sizable environment, any sort of enterprise environment, you're going to be generating tens of thousands of alerts, right? So there has to be this next level and probably several levels of filter that really kind of filter out those that are important for me and those that really, really aren't, right? For example, an alert about a vulnerability that has no fix. Right? What am I supposed to necessarily do with that? It's not that it's information I don't want ever, but it's not information that should supersede anything else that truly, truly does need my attention, and that I can sort of approach right now.
Yeah, that's a really good point. And this alert fatigue, and you guys are right in putting it number 1, because it's one of the greatest challenges that confronts all security management today. Because you've got multiple tools and all of them are reporting in their own way, coming back in. And now you've actually got tools that talk to tools to try to interpret what other tools have done, all trying to minimize this risk to some degree. That Orca took the time and used AI and built all of that in. So many of the other tools out there right now are all just siloed, and they don't talk to each other. They don't understand each other, and they sure as hell don't alert in the same way. And it's all just like hieroglyphics. So one of the great things that Orca has done is it's abstracted all of these alerts, provided intelligence to it, and allows you to actually see it in English that an IT person or a security person could understand what they need to do. And one of the main things here, kind of like your point 2, is it helps you prioritize what that is. And that is, in an organization where you're confronted with multiple threats, prioritizing which ones you need to deal with first is absolutely the most important thing, because you can't fix everything all the time. You're always going to have some weakness. So with Orca, it actually helps you, provides you that guidance, shows you that intelligence, and allows you to make informed decisions.
That's a really good point. You're never going to get to the bottom of that vulnerability list, right? So having something that sort of can work outside of this traditional vulnerability or malware detection kind of silo, understand more context, is absolutely key. So, let's say we get prioritization down. The next problem is, does the alert have enough information in it for me to be able to solve the problem, right? And does the platform that generate the alert have enough kind of information, enough capability for me to, explore around and understand? And I'll give you a really good example. We had a customer detect an occurrence of malware, and it was malware that was relatively not understood yet. And so, they use other features of the platform to be able to tell, hey, are people trying to brute force login? I know that's part of what this malware does. After reading up on it, we could tell that. And then we could also tell that there's a kind of a CPU meter assigned with every sort of computational resource in Orca. They could also see that, post when this malware was detected, they had definitely more CPU utilization on an ongoing basis. And so, it's about having enough information in the alert, and then does the platform that you trust and depend on to sort of find these things give you enough, sort of side capabilities to truly dig in and investigate.
So Patrick, I'll tell you, everything that you just said is absolutely correct. And, getting all these alerts and getting intelligence in the alert is a very important thing. But even more important thing is the aggregation of alerts. Anyone that's seen an alert just for one software package that is old you could generate 5 alerts, 10 alerts, 20 alerts, or like on Microsoft Patch Day, where you've got all these patches, you can literally get 1,000, 2,000 or more alerts. So aggregating all of those alerts together so that you can understand, oh, this is because this Java package needs to be updated, that tells you right away what you need to do. You really can't do that. And when you're looking at a cloud platform where you've got all kinds of VMs, containers, CPUs, memory, and you've got different things going on there with the applications, it magnifies the issue and it multiplies all the different things that you need to look at. So without something like Orca that's giving you actionable context and then aggregating that alert up so you know exactly what you need to do in a cloud environment, it's damn near impossible to figure out what it is you need to do to secure that vulnerability, that weakness or that gap that you have out there. So all of these things lead up and they allow you to pinpoint where the issue is, allows you to target that particular patch, allows you to target that configuration, because one of the cool things that Orca does, it'll show you misconfigurations. So it'll tell you basically what you need to do to allow you to remediate that issue a lot faster.
Yeah, and we'll definitely try to underscore that, in the demo, how we do this kind of roll up of alerts and aggregation. Because you're right. I mean, a platform can either tell you, hey, patch your system and you'll take care of these 1,000 alerts all at once, or it can deliver those 1,000 alerts and put the onus of context and figuring that out kind of on you, the operator or security admin, right? So absolutely right. We've talked about how context is so important. Let's dive a little bit deeper into that. And we've also talked a little bit, probably not as much as usual, around this notion of side scanning and how Orca does not need, an agent in your workload, a scanner in your network, really no ops code running at all in your environment. To understand, again, powered by that cloud sort of sub-storage layer. We've talked a little bit about that, but we've talked less about kind of what context means, right? When I've heard that term kind of thrown around quite loosely. So let's get into exactly sort of what that means. So, whether your workload is a traditional VM, whether it's a container on a VM, whether it's hosted as a container as a service on any of the platforms that we support, Orca understands, which services are running, what the firewall configuration looks like, and quite a bit more. And at the same time, Orca is reading metadata in a read-only fashion from your cloud provider, right? And this is the same kind of data that a CSPM would kind of read and in the same fashion. And it's focused on the configuration that is, quote unquote, above your workload. Concepts like, cloud security groups, network configuration, identity and access roles and policies. Orca combines all that information into what we consider a context map. And Orca builds this context map by, again, mashing up all this deep workload discovery detail combined with this cloud context. So Orca will, discover cloud assets. And in fact, Orca exposes information in kind of this asset inventory interface of the service, which I can show you in the demo if we have time. We'll also identify asset roles, which resources are configured to do what and the permissions they have. We'll identify connectivity, how resources are connected together, which networks are public facing versus those that aren't. And then and only then Orca will identify, all of those risks with that sort of contextual awareness. And maybe the best way to talk about this is just do a quick example. So, if we take a look at these two workloads, server 1 and server 2, both running a web server that has a vulnerable library, let's say in this example, vulnerable to remote code execution risk. For the sake of the example, right, assume the vulnerabilities are identical on both of these servers. A context-less vulnerability scanner, like an agent, would simply report this vulnerability with its static sort of CVSS score, right? And both workloads would end up having the exact same score. After all, they are the very same vulnerability, right? Orca, on the other hand, deduces from the cloud configuration that the server on server 1 is internet facing, and therefore the risk level is imminent compromise, right? Server 2 is not internet facing and cannot be reached directly from anywhere but a particular host, and therefore the risk is risked as hazardous, right? Still important, not a low informational alert because, we've got a critical vulnerability, but certainly not as critical as that workload that can be reached from the outside. So that we're on to number 2. We talked about 1, alert fatigue. Our second risk is workload coverage. Our customers tell us that deploying agents sort of universally is just about next to impossible, right? Even in organizations with sort of a dedicated function to do that. And this is especially true for organizations who use cloud across the entire org, not necessarily a sort of a cloud first mandate, but where cloud is used in several business units. And I'm curious, Michael, what's your perspective on deploying and maintaining agents as it relates to coverage and visibility?
It's really hard, especially when you're in a multi-cloud environment. Agents behave differently, they act differently, and some products aren't even available for every cloud provider. So agents are hard to maintain, they're hard to keep updated. It's hard. It just, you want to get away from them as much as possible.
Yeah, I mean, for sure. And you think about this sort of new paradigm of DevOps or even DevSecOps where you want to involve security much earlier in the process, yet you don't want to step on the toes of innovation, right? You don't want to put these roadblocks in the process of this sort of mandate in DevOps, which is to do the exact opposite. Yet, whether it's DevOps or whether it's trying to work with other business units across the org to do things in a very standard way, it's tough. As the organizational sort of needs and reliance on cloud grows, that gets more and more difficult, right? And that's really not to speak of the fact that if you're approaching this problem with workload agents, back in the data center, that made a lot more sense than it does in the cloud. I would argue even then it was kind of fraught with problems. But on the cloud side, now we've got this notion of workloads that spin up and spin down in a matter of minutes. Each time inheriting a new identity, certainly from an IP address perspective, but from multiple perspectives, right? And if you're used to agents and scanners that rely on IP addresses, I mean that's a way of measuring that we simply can't leverage right in the public cloud, and so we know that it's these gaps of unprotected workloads that get us breached, right? It kind of harkens back to that Gartner stat of the vast majority of all these breaches will be our fault, not leveraging kind of the security controls properly. And so again, I think it's technical, but it's also about kind of getting that agreement across your organization. Sorry, Michael, I interrupted you.
Yeah, I was going to say, Patrick, you're right. And as organizations move more and more to serverless environments, because let's face it, who wants to pay for a computer that isn't always actively doing anything when you can just spin it up when you need it and spin it down when you're done with it? It's a much more efficient and a hell of a lot cheaper structure to use going forward. So you can't put an agent on something and then tell the business, oh, wait, I got to take it off. Oh, wait, I got to put it on. That's insanity.
That's a really, really great point, right? We're so used to thinking about, because we're used to our data center operating sort of paradigm, that workloads mean VMs, and that's not the case. Whether you've got VMs, containers, storage buckets, or as you suggest, sort of functions as a service, it's all about scanning, all of that, right? And Orca users kind of see the foray we've taken into sort of serverless and scanning functions as a service for secrets, and that's absolutely intentional and part of where we know cloud is headed, and of course that's where cloud security has to be headed as well. Okay, our third risk: vulnerabilities and malware. We know that vulnerabilities, usually as they're associated with poorly aging software that hasn't been patched or updated, they are one of the primary attack vectors that those with bad intent leverage, right? Which makes our continual vigilance so important. If you've run any sort of vulnerability management program before, you know that the main problem with the strategy is sort of the noise, so to speak. We've talked about that in the context of alert fatigue. Thousands and thousands of vulnerabilities will exist in the average cloud deployment. do you want to know about every single one? Probably not. So what is the criteria, right? What about those that are exposed to the outside? What about those, and I think I mentioned this earlier, that have a fix versus, those that don't? Of course, the vulnerability severity has to play into it, but not all of our cloud environments look the same. And because, Orca is out of band, when we do find a vulnerability, we can do quite a bit, we can attack the problem in quite a bit different way than an agent does, right? We can and we do spend a lot of resources from a sort of computational perspective, if you will, and a disk I/O perspective, scanning your disks and looking for vulnerabilities in malware, right? Even advanced, polymorphic malware, for example, that changes its characteristics over time. Orca chases that well, right? Because we don't have to worry about competing for the resources in our customers' workloads that agent-based solutions do. So I think context is important. The very different approach that Orca takes is important. And I'm interested again in your take, Michael.
Yeah, I'll tell you, Patrick, one of the things that is important to especially larger organizations is what I'll call dual control. So you've got an agent on the desktop, you have the best agent, you've got it updated, 5-10 times a day. But there's malware out there, especially ransomware, that it'll find your particular agent and turn it off. Well, now what do? You're completely vulnerable on that desktop. This is where something like Orca can come along, scan all of the components within the system right down to the CPU level, and tell you what your vulnerabilities truly are, on a near continuous basis. That's hard to replicate with any sort of an agent, and especially on, I'll call it mission critical and really important environments. You really need more than one tool to effectively have that dual control, especially in financial services organizations and things where you're running mission critical gear. You can't afford that sort of vulnerability or gap in your controls.
Yeah, that's a really good point in that, definitely, especially on the side of antivirus, malware detection, there is some malware that's kind of looking for those commonly used engines, right? Rootkits are good examples too, that kind of completely bypass that detection plane. But, because of that out of band kind of approach, as you suggest, Michael, they don't fool Orca, which is, it helps me sleep at night for sure, right? When I think about technology that's kind of built to thwart the detection mechanism, and Orca isn't susceptible as that at all because it's done out of band. So yeah, it's a really, really good point. So our fourth risk out of 6 is misconfigurations. Shouldn't really surprise anybody that this is here, right? We've heard from Gartner, I think the revised stat is almost up to 99%. Basically all of the breaches are our fault, right? And I think this is why you see vendors still evangelizing so much around the shared responsibility model. It seems like it should be table stakes and everyone should understand it by now, yet we know there is this kind of prevailing mindset that when we move to the cloud, more is sort of auto magic, if you will. Security is sort of taking care for us. We know that's not true, yet we also know there's a gap in that skills base for those who really do understand the delta between security controls in the data center versus those cloud security controls, and I think that's probably what leads this whole initiative of of misconfigurations is a bit of a knowledge gap.
Yeah, you're absolutely right, Patrick. And it's even worse than what Gartner, I think, and a lot of others really have articulated. Think about the whole pandemic. All of these companies were forced to survive in a way by moving to the cloud, pushing everybody home. And when they did that, they didn't necessarily have the time that it took to be able to, okay, let's have security review everything. It's like, do or die. You've got to be able to actually get your business going. So you have all these people that may or may not have used all these different cloud services and cloud providers before. They're suddenly pushing all of these mission critical business applications, data, everything up to the cloud on all these different vendors, and they're in a rush to do it. It's a survival. And the same with pushing people home. And whenever you rush, oftentimes you don't make a thorough analysis of everything you should do because you're firefighting, and what happens, you might make a mistake or multiple mistakes. And these gaps that are left everywhere, where it's at the cloud provider, where it's in the application, where it's in config settings within a specific VM, or it's in the work from home access, or you're recycling one key for everyone in your whole organization. All of these things are just complete misconfigurations, and the pandemic, unfortunately, has been, open field day on all of the bad guys out there. So by using something like Orca, you're able to scan across all of that, and you're able to see it and get visibility into it. Otherwise, you're kind of blind to it.
That's a good point. It takes some of the heavy lifting off of that skill set needed, right? Orca does some of that heavy lifting and categorizes and doesn't put the onus of context on the on the security administrator, right? It kind of takes that into consideration, and the output is something that's actionable with maybe less deep knowledge of kind of what the cloud entails. And we have this kind of, to your point, Michael, this new set of organizations that maybe we're trying to do this in a data center. Try procuring enough infrastructure to build a COVID era data center, right? A lot of that has just been pushed to the public cloud. Instant on, often that instant on means security comes last, if ever. And as kind of the middle tile in the slide suggests, it's not a one-to-one kind of comparison where you had a set of redundant firewalls in your data center to manage. Now you've got hundreds and thousands of them, right? So you've got a lot to learn in a short period of time, and Orca can certainly help you with that gap.
Hey guys, I got a question from the audience, and thank you for that. I love getting questions during the presentation itself. This person's asking, what support does Orca provide for Kubernetes clusters?
Yeah, it's a great question. Given that our support is for kind of the big three, right? AWS, Azure, and GCP. We support every kind of way you can run sort of a container across those three platforms. Kubernetes, vanilla Kubernetes or not. So that includes Kubernetes on Azure. It includes GKE on Google. And it includes ECS, which isn't Kubernetes, EKS, and Fargate. Really, basically, truly every way you can run a container across kind of the big three. So, yeah, full support there for sure. Agentless and daemonless support as well.
Thank you.
Yeah, my pleasure. Okay, on to our fifth risk, lateral movement / adjacent risk. Just before this webinar, I presented another that was kind of on the topic of lateral movement, and I think, it's a loaded topic, right? Lateral or adjacent movement is the practice, as we know, of attackers moving from sort of resource to resource in search of their goal or of the highest, value data or system. They look for network information and credentials in a number of ways to help them sort of facilitate this movement, right? And it's critical for us to not only find those conventions that facilitate lateral movement, like sloppy firewall controls, cloud credentials that provide access, or, secure shell keys that can be utilized to remote into systems that are closer to an attacker's goal, right? But then also to understand, with the help of context, just what and who they provide access to, right? And I think I mentioned this before, although microsegmentation has created sort of more opportunities for tighter security controls, it also means that we have way more firewalls to manage, right? And of course, that means the chances of making mistakes go up. So our continued vigilance is important here, both kind of at that host level around, the kinds of things we leave on machines that might lend to the ability to move laterally, but also the controls around each workload as well. And then our last risk, authentication risk. Authentication risk really has to do with being diligent on all things identity and access related. And that means everything from crafting and enforcing proper password and access or login policies, and I'm thinking of multi-factor authentication here for sure, to ensuring our logging is complete and secure, to having a predetermined policy for handling exceptions, right? We know that misconfiguration on the authentication side often stems from, a last minute kind of access control demand, somebody taking a shortcut, providing more privilege or kind of a sloppy way to provide that access, and then, never going back and kind of, we all get busy, never going back and kind of cleaning that up after the fact. And at the host level, we have to ensure that, User accounts are hardened as well, where no commonly used usernames and passwords are utilized, no old passwords that have been hacked and previously published as part of a breach payload, and that no users external to our organization are configured to be able to access our resources really on an ongoing basis. So with that, I'm going to keep control of the slides for you, Michael, but hand the floor over for you to talk to just a little bit about your problem state and your journey to find Orca.
Oh, thanks, Patrick. So one of our big security challenges was the cloud. Like all companies, you're going to have some or all of your environment to the cloud. So what you've got to do is you obviously need visibility into it. Before Orca, our visibility with some of the tools that were available in the cloud providers only gave us about 20% into those different areas. So with Orca, we were searching for a tool like Orca, which would give us total transparency and visibility right down to the CPU level. Because if you've got an important task, you want to make sure that the CPU you're running on has as few vulnerabilities or hopefully none, depending upon the provider. Because unfortunately now you've got to consider that for where your things are running. We, like a lot of companies, are moving very fast. We've got certain environments where we literally make changes to it every day to improve customer experience and to perform the best possible operational capability, again, for our customers. So we try to move very fast. And in doing so, one of our challenges, because, like everybody out there, unfortunately, you can't go out and devote your entire budget to just security. You've got to leverage important tools and spend your money wisely. And that's where, this alert fatigue is such an important thing, because we all get bombarded by these messages. And one of the other things is that by doing that right, it means you don't need to have an enormous number of people all trying to do the same thing, all trying to figure stuff out. It allows you to optimize your team and ensure that when something happens, you know exactly what to look for and how to address it. Obviously, like anything else, you want to make sure you resolve vulnerabilities when they're really small before they get really big. And by having a lean team that knows what they're doing, and by making sure they're targeted on their alerts, you can't beat that combination.
Yeah, as I advance the slide, Michael, that 20% cloud visibility, that's a scary figure.
It is. And most companies don't even know that they have that gap. They don't know what they don't know, kind of like the old saying. So now we've got complete visibility into a multi-cloud environment, which is, I got to tell you, that's pretty darn slick. We've got risk-based prioritization of our alerts, so we can look at it and go, oh, wow, that's something we have to address now. Kind of like your earlier internet-facing example. The old tools had exactly the same priority. With Orca, since it's got the context and it's got the behind-the-scenes AI doing the hard work for you, your staff is much more efficient at what they do. And as I mentioned before, you can use one tool for your different cloud environments, because let's face it, we're all multi-cloud today, whether you want to admit it or not.
That's right.
That's just a fact of life. And serverless, I will tell you, we were an early adopter in serverless. We were, back when it was in beta, we were experimenting with them, and we use these heavily in our environment. It is a fascinating technology. I love it. And I got to tell you, it's really one of the best cloud environments there is, because if you can spin up 1,000 servers and spin them down, and one of the good things about Orca is it lets us protect them all and make sure that we've done it right. Otherwise, you kill them all, you change your setting, you redo it. You can't beat that.
Right, and that's one of the use cases we talk about when we think about agents, right? Agents have a really difficult time kind of satisfying that ephemeral use case of something that really only exists for minutes.
Yeah, and I'll have to tell you, we were absolutely blown away and astounded by the visibility that Orca gave us into our cloud environment. We were just like, oh my God, we can get access to that. Like, we knew it was good, but when we actually saw all of the scans, we were just like, we can't live without this. I mean, it was just an incredible tool. And, I can tell you, as the executive that oversees security, it definitely gave me a peace of mind that, I was extremely concerned about. I worry about things, and I want to make sure that we are protected and we put as many protections as possible in place. And one of the great things about Orca, I'll use the analogy of, kind of driving down a street and you see a house, or when you see those house shows, on TV, where, the people walk in and they, look behind the wall and they go, oh my God, the whole wall is rotted and, this house is a disaster, but we couldn't tell it, by looking at the street or walking inside the house. Orca gives you that X-ray vision. It really is my best way of describing what it lets you see. It lets you see everything within that structure before you do anything. And for me, that's really innovation without risk, because we can do all kinds of stuff. We can move really fast, and we can make sure that what we're doing right along the way, as we do it with the speed of business, that it's secure. You can't beat that. And because of that, you don't need to have 30 tools, out there, exaggerating slightly, but it's, probably a handful of tools where you're trying to fill gaps, and none of them really does it very well. So by not having all those tools, we save a lot of money. And because you don't have all those tools, you're not trying to train all your staff on all these different tools as well, because let's face it, nobody's an expert on everything. And software is complex, especially where security is concerned. And you've got high stakes as well.
Yeah, that's a great point. No one's an expert in everything, and finding those people who are experts in many things is a time fraught process and expensive for sure. We covered a lot of it today in terms of the highlights, but Michael's case study on the Orca website is chock full of really good kind of intelligence and findings and insights. So I urge you to take a look at it, along with really any of the other case studies we have there. We have many. We've really made that a focus of our efforts here at Orca. And with that, I know we're short on time. We're pretty much 1 minute away from the end. If you can afford to give us just a little bit more, we're going to take it. I'm going to do about a 5-minute demo, and then we'll wrap up. So let's do that.
Yeah, and while you're pulling that up, Patrick, someone asked a question, and maybe you can show this off in the demo. It was around context-based access control. Now, we're not an identity access management solution, but we do some things around like authentication risk and policies that aren't being adhered to and things like that. So if you have time in the demo,
sure,
if you touch on that'd be great. And then also, you can go 10 minutes. Don't feel too stressed here. It's okay.
Sounds good. Yeah. So the first thing that we often talk about isn't any of the intelligence. It's usually actually, how you get started. It's really simple. Basically, you define a role in a policy. You connect Orca to that role in the policy, and that dictates what Orca can and can't do kind of in your environment. And it's the same whether you're onboarding with AWS, Azure, or GCP. It's a very straightforward process. We'll guide you through as much as possible. If you've done this before, you can literally do it in less than 60 seconds. And so the integration, the deployment is kind of the first really interesting piece, but then understanding that that's the only install you'll ever do is kind of the other side of that, right? It's not like you have to integrate per resource. You do this kind of one and done installation. And from that point on, Orca has kind of full perspective of everything you do in that account, from a workload perspective, from a data bucket perspective, from a remote database perspective. Everywhere you can have data and therefore risks, Orca will know about. And so, for a first-time evaluator, that's it. That's the deployment process. Orca begins sort of side scanning all of those resources that are found and generates what you see here. And this is your dashboard, right? So these are kind of the top alerts in each category. We'll spend a few minutes here, and then we'll look at kind of into the more defined alert inventory. But here you can see a bunch of examples of malware, right? Malware we've discovered, where it's been discovered. You can certainly get a lot more information about each alert. We're going to do that, but let's kind of scroll the list a little bit first. Actually, for this one, let's dive in a little bit deeper, because there's a real good example of context here. So you see a couple of different alerts here. These web service unpatched have to do with, a poorly aging version of software, in this case, web serving software, Apache, that hasn't been, patched in a long time. And if we take a deeper look at this, we can see an example of some of what Michael, really liked. This alert aggregation will tell you that, look, you haven't patched Apache in such a long time that all of these CVEs have to do with that. Now, we could just dump these CVEs to you, right, in a pure kind of information dump sort of way, but we don't. There is a kind of a different interface where you can go and get that traditional kind of vulnerability perspective if you're doing so for an auditor, for example. But in these alerts, we're rolling up these findings into something that's actionable. If you patch Apache, you'll take care of all of these different vulnerabilities. And that's a really important kind of takeaway from an alert fatigue perspective. The other thing that's important here is, let's take a look at that one. Let's open this one up in a different tab. And I'm full screen, so you can't quite see my tabs. And then let's look at something slightly different. And maybe you can see the filters on the left-hand side. Let's just open this up. So let's look at web service unpatched only. And you'll see that these are almost the same update. The software is a little bit different. Nginx is a different web server than Apache, but one is graded as this orange likely compromise, and one is downgraded to this hazardous. And you might ask yourself why. I mean, these are very, very similar alerts. But if you peer into each one, you'll see that Orca looks at not just the attack vector, kind of how close it is to the outside, but also different attributes about this machine. You can see that this particular web server is on, it has a public IP, and it's listening on port 80, right? So it's got all the criteria to add up to this, kind of imminent compromise sort of alert. Whereas if we scroll down to one that's risk slightly less, you'll notice that it is actually turned off. So it's not that it's not important. It's still got, this kind of hazardous kind of grade to the risk, but because it's turned off, nothing is imminent right now. Out of these two alerts, which one should you look at first? Clearly the one that's turned on and is remotely accessible. Of course, once you've taken care of kind of that category of compromised resource, you want to move to these ones, because a stop resource can be turned on, right? So that's why it's not purely informational. It's still hazardous. It's just not full of kind of imminent compromise potential. And that's, again, part of the power of that the context can bring you. Let's take a look at lateral movement. This is another really good example of sort of context. You heard us talk about passwords in shell history. This is a certain kind of alert that Orca will find. As approved good path administrators, we often do have to issue commands that have passwords on them. Of course, if someone harvests credentials and can log in as anyone trusted, they can scroll that shell history, it's called, and find those passwords that you used on the command line. And so that's something that Orca calls out very accurately. And again, if it finds them in a machine that's running and exposed, you get that hazardous kind of risk tolerance for the alert. And again, everything we do has that sort of context mixed into it. The other kind is, when Orca happens to find a rogue SSH key, right? Maybe not rogue, but in this case, we're able to see that this key that it found actually provides root level access into 4 different machines in this cloud account. And again, that's only possible because Orca looks at the cloud account from a top-down perspective and is doing this analysis on every single resource, right? So we find the other half of this matching key in the authorized key section of these 4 different hosts, of which you can also click on and get a risk profile because Orca has side scanned and sort of mashed it up with context already, like this workload. So again, context is prevalent really all the way through the tool and through the alerts. We already looked a little bit about at the alert interface. This is kind of Orca's next generation UI that launched about a month ago. If you want to look at those informational alerts, you absolutely can, but the default view is, hazardous, imminent, compromised, and already compromised. That's sort of reserved for malware instances that we have found that, obviously do indicate that there's been sort of a compromise of some fashion. But you can sort of walk a timeline. We can say, hey, show me this alert that occurred a month ago, but now is apparently solved. I want to see the characteristics of it. We can do that kind of with either the time filters, or on the dashboard we have a bit of a time machine on the top right hand side that you can use to scroll easily as well. But we can also get down and say, okay, show me all of my malware alerts. You might think that every single malware alert would be kind of this already compromised, but we do have some that are risk-less because the machine is sort of necessarily not public or turned off, for example, or is only addressable on a private IP, not a public. So even malware isn't necessarily all the highest severity. Most of it is because it's an indication that you already do have compromise. So I think, I know that's a real crash course into the kind of intelligence that Orca generates, how it does it, right? How we onboard those cloud accounts in a one and done fashion. And then from that point on, Orca really has full perspective. And, we don't make any differentiation between whether your workload is an instance, is a container. Of course, in the inventory section where we filter for the things we can look for just containers or just VMs or network attributes or just our storage buckets. But from an alert perspective, an alert on PII that is found in a VM is the same as an alert that's PII that's found in an AWS S3 storage bucket. So on the alert dashboard and in the alerts interface, it's really kind of alert centric. And then on the inventory side is where you can use this, yes, for security consideration, but a lot of Orca customers also use this as Michael suggests. It's a nice roll up, especially if you're a multi-cloud customer, right, across AWS, Azure, and GCP. You'll have a great roll up of all of your containers across all three providers, for example, here in the inventory interface. So I think with that, I'll stop and we will focus back on questions.
Thanks, Patrick. And sure. I know that was a blazing fast demo, and I encourage folks to sign up for a personalized demo, which I put the URL for that in the chat there. And I see some questions coming in. Thank you for that. Someone's asking, what permissions must I give Orca so it will work?
Yeah, that's a good question. Obviously, when we say it can see your whole cloud estate, people start scratching their heads saying, how much can it see? Can it see the things I don't want Orca to see, right? And so Orca leverages some built-in privileges of each platform we leverage. In the case of AWS, for example, there's kind of this managed security policy by AWS called Security Audit, which gives read-only access across kind of the breadth of services that AWS maintains. So we leverage that, and that is a policy managed by AWS. We can't sneak things in there, for example, for extended kind of visibility. And then we use a small addendum to that lets us, take a snapshot of a disk, evaluate it, re-encrypt it, of course, because nothing is ever not encrypted in the state of Orca operations, and then delete it. So for the most part, it is that managed security audit kind of permission model from AWS.
Thank you. Another question here. I use Splunk. Does this for everything? How does it work? Does it work with Splunk? And if so, how does that work?
Yeah, it's a good question. We didn't have time to talk a lot about the sort of integration potential with Orca, but yeah, our vision is that it fits into your workflow, not the other way around, right? As you evaluate and purchase Orca, we don't want to put the onus on you to figure that out. So yeah, we do. We have a lot of ways to sort of extend Orca into SIMs like Sumo or Splunk or even Azure Sentinel, into workflow tools like Jira, ServiceNow, into Slack if you're more of a chat ops or a chat SecOps kind of a fan. Lots of different integrations possible, but yes, Splunk specifically for sure.
I have two more questions here, but if others want to jump in and ask more, I encourage you. We can stay on a little later. That's no problem. The first or the second I see here is that this person's asking, okay, I don't need agents, but what are the dependencies to utilize Orca? Do I have to set up Lambda functions? Do I have to set up VMs as scanners? What do I have to do?
Right. Yeah. Some of the illustrations we used kind of quickly today probably didn't make that clear, but there's really, unlike other tools, maybe that try to peer kind of deeper into your cloud estate. There's nothing for you to set up at all. No dependence on glue in the way of Lambda functions to tie, an alert to a finding, or no need to spin up scanners. Orca does that kind of ephemerally and on the go. Right. Scanners don't sit around. Once we find that you've debuted a new workload, Orca will spin up a scanner in its own account. Through that trust relationship, it'll scan your workload and sort of bring those findings back to you. So the short answer is no onus on you, kind of the customer, to provision anything.
Great. And this is the last question, unless someone jumps in with another. This person's asking, does Orca only scan live infrastructure? Can I scan virtual machine images or container registries?
Right. So we did talk about kind of as you spin up workloads, Orca finds them and scans them. There is certainly a portion of functionality in the product where you can say, hey, I'm building a new machine image in Amazon speak that's an AMI. Scan that before I even deploy it the first time. Or I'm building a Docker container. I've put it in my registry. Please scan everything that's in the registry before I deploy it once. Right. It's part of that sort of shift left perspective on security, and Orca supports that as well. So you can have confidence that your workloads don't contain malware or vulnerabilities before you even provision them the first time.
Wonderful. Fantastic. Well, that was the last question. Patrick, Michael, thank you so much for your time today. It was a fascinating presentation, and this concludes our webinar. Thanks, everybody.
Thank you.
Thank you.